When you configure an interface with an IP address, it is connected to some switch or local segment. This means that network can only be used on this switch or connected interface. This is considered as a single broadcast domain. But let's say that you want to extend that same network to a different floor or building. Well, using VLANs, you are able to do exactly that. For a VLAN, that single network is configured within a single VLAN using a unique identifier. And that VLAN can be carried to other switches on the network for extending that IP subnet to different floors, buildings, or even locations. So in this picture here, for example, we have the network of 192.168.10.0 that is configured or a part of VLAN 10, the unique identifier. So VLAN 10 will be extended all the way across to other locations or buildings, where this PC here, PC2 and PC1, are part of that same network, basically extending that network from building 1 to building 2. Now, what about this scenario? Let's say that you have multiple VLANs on your network. We can have one for our user network, which is VLAN 10. We have one network for our server farm, which is VLAN 20, and maybe a development or lab network, which is VLAN 30. Now the question is, how do you extend multiple VLANs between other switches? So each switch port can allow support of a single VLAN. So if you have 3 VLANs, like in our case here, then you could use 3 separate cables between each switch for each VLAN, something like this. Well, that can get very messy very quickly and could lead to layer 2 loops or broadcast storms, which could bring down the entire network. Plus, if you add more VLANs, it will complicate your network even further. The other option is to configure these switch ports, these right here, as trunk ports. And these trunk ports can be 802.1q trunking or ISL trunking for the encapsulation. But the most common is 802.1q, the industry standard supporting hundreds of VLANs across a single interface. When you configure trunking, it must be configured on both ends or it would not work. So if we have these 2 switches here, 802.1q trunking must be enabled here for these VLANs, and it must also be configured identical on the other side. So trunking is normally configured between switches, but it can also be configured with routers or firewalls to even computers and servers if they support 802.1q trunking or VLAN tagging. So for each VLAN that is extended over a 802.1q trunk interface, it must be tagged VLANs in order for traffic for that VLAN to be extended across. That is very important. In our environment, based on our design, this is how we'll be configuring VLANs and 802.1q trunking based on data center best practices. Let's talk about this design a little bit further. Our network will consist of 4 production server farm networks. These server farm subnets and their descriptions are listed below. We will have an infrastructure server farm, one for applications, network management, and development. So each of those networks will be associated to their own VLAN. And these VLANs will be added on all of our data center switches since we are using BTP transparent mode. So for example, we have our infrastructure network, which will be the main network that we will be using. And the network for that, or the subnet, will be 10.0.0.0/24. This will exist in VLAN 10. So the same will apply for the other server farm networks and how they'll be configured in our environment. Now, since we are using multiple VLANs, they also need to be extended between all of our data center switches. Therefore, all of the interfaces in our topology will be enabled as 802.1q trunking interfaces. Those interfaces will be configured for trunk security, listing only our production VLANs as a best practice. For the native VLAN, we will be adding a null or a bit bucket VLAN using VLAN ID 999. This will be an unused VLAN that will not have any production traffic, and it will help against possible VLAN hopping attacks. It's also important that our production VLANs be routable within our data center. Therefore, all of our VLANs will be configured with a layer 3 VLAN interface called an SVI interface. Now, since these routable interfaces will be configured on the core layer, this is important. We will also be configuring HSRP, but that will be covered in a later video topic. So those are the details for how we will be configuring VLANs and trunking in our data center environment. Let's start our VLAN and trunking configuration on our network. Starting on DC1, we will add all of our production VLANs that will be used in our environment. So it'll be VLANs 10, 11, 12, 13, and our bit bucket VLAN of 999. Next, we want most of those VLANs 10, 11, 12, and 13, to be routable within our environment. This will allow us to enable HSRP, which we will do in a later step. Now, before we can make our VLANs routable, we need to enable that feature on the Nexus switch, which is called Interface VLAN. So let's go ahead and exit out, and we'll type in feature, Interface VLAN. Now we can create our VLAN interfaces, our layer 3 VLAN interfaces, also called an SVI. So this configuration is very similar to Cisco IOS, but we have a new enhancement for how we can put in the subnet mask, which is very nice. So let's add a layer 3 interface for VLAN 10 by doing interface VLAN 10. Okay, then let's configure the IP address and subnet mask that we want for VLAN 10 based on our design. So it'll be 10.0.0.253/24. Next, let's do a no shutdown to initialize this interface. And that is it, all basic Cisco networking. Now let's add layer 3 interfaces for the other server VLANs on the switch. Do VLAN 11. We'll configure the IP address, mask. Let's shut down. Let's initialize this interface. Do the same for VLAN 12. The mask. Let's initialize this interface. And let's configure the interface for VLAN 13. The mask, and let's initialize the interface. Since we have multiple VLANs that we want to extend throughout our data center topology, we need to enable 802.1q trunking for all interfaces connected to the other switches. We will first enter the range of interfaces that DC1 is connected to, which would be DC2 and our 2 access switches below. And doing this, what we apply here will be applied to multiple interfaces at once, so we won't need to waste time entering the same commands again and again. Okay, so first we want to enable these interfaces as layer 2 ports. So let's go ahead and do switch port. Next, we want to specify the native VLAN that will be used. We don't want to use the default, which is VLAN 1. We will set the native VLAN to use our bit bucket VLAN, VLAN 999. Next, we will set these interfaces to be trunk ports and not dynamic ports. Oops. Okay, and next, as a best practice, we will enable trunk security, specifying the VLAN tags that we want to be allowed over these interfaces. In our case, that will be all of our server VLANs, VLANs 10, 11, 12, and 13. Okay, and lastly, let's initialize these interfaces if they are already shut down. From there, we want to replicate the same configuration to the interfaces on the other data center switches. So let's go to DC2. First, let's add all of our production VLANs. So it'll be VLANs 10, 11, 12, 13, and our bit bucket VLAN. And next, let's enable the interface VLAN feature. And now let's add layer 3 VLAN interfaces for each of our server VLANs on the switch based on our design. So this is going to be for Vlan 10. Let's initialize it. Let's configure the interface for Vlan 11. Do a no shutdown. We'll do the same for Vlan 12. And finally, Vlan 13. The IP and the mask, no shutdown. Finally, let's enter the range of interfaces that DC2 is connected to, which would be DC1. Okay, and our 2 access switches below. Okay, so let's enable these interfaces as layer 2 ports. Next, we will set the native VLAN to use our bit bucket VLAN of 999. Next, we will set these interfaces to be trunk ports. So mode trunk. Next, as a best practice, we will enable trunk security specifying all of our server VLANs, including Vlan 1. I forgot to mention that. Okay, and lastly, let's initialize these interfaces if they're already shut down. Next, let's go to DCA1. Here, let's add all of our server VLANs. So there'll be VLANs 10, 11, 12, 13, and our native VLAN. Now these VLANs, with the exception of our native VLAN, will only be routable on our core layer. So we do not need any layer 3 VLAN interfaces created. But we do have a server that is connected to port Ethernet 1.1. Let's go under that interface now. And we'll put this port into Vlan 10. Next, we will force this switch port to be an access port, which is like an edge port. Next, we will manually set the speed for this port to use 1 gig and not 10 gig. Okay, and let's initialize this interface if it is already shut down. Great. So now we want to configure the uplinks that connect up to DC1 and DC2 based on our design. So let's enter that range of interfaces up to the core layer. Okay. Now these ports are already layer 2 ports. So let's go ahead and set the native VLAN to use our bit bucket VLAN. So say native VLAN 999. Next, we will set these interfaces to be trunk ports. And then next, as a best practice, we will enable trunk security specifying all of our server VLANs. And lastly, we will initialize these interfaces if they are already shut down. Okay, now let's go to DCA2. And here, once again, we're going to be repeating really the same steps. Let's first add all of our server VLANs. This is Vlan 10, 11, 12, 13, and of course our bit bucket native VLAN that will be used. Okay, we have a server that's connected to port Ethernet 1-2. And we'll put this also in Vlan 10. This is server 2 that's connected to this. Next, we will force this port to be an access port. We will manually set the speed for this port to be 1 gigabit. Oops, wrong command. Typed the wrong command there. Okay, and let's initialize this interface. Do a no shutdown. And once again, we want to configure the uplinks that connect up to DC1 and DC2. So let's enter that range of interfaces up to the core layer. And these ports are already layer 2 ports. Let's set the native VLAN to use our bit bucket VLAN. Next, we'll set these interfaces to be a trunk port. And let's go ahead and set up trunk security, specifying all of our server VLANs, including VLAN 1, the default VLAN. And lastly, let's initialize the interfaces. So we are now finished with all of our VLAN and trunking configuration in our topology. Now let's confirm the VLANs that we just added. To do that, we can view the VLAN database by using the command show VLAN. And here we see all VLANs that we added to our primary core switch, which are VLANs 10, 11, 12, 13, and of course our bit bucket VLAN. You'll also see the VLAN mode, which is right here. So we see all of our VLANs that we added. And you'll see that the VLAN mode for those VLANs are reflected as CE. And CE stands for Classical Ethernet, which basically means LAN switching. The same VLAN and trunking that we can do in a LAN campus environment. Now there are different VLAN modes that can be enabled for a VLAN, such as Fabric Path, but we will cover that in a separate video where you will see the difference. Also on this page, you will see which ports on DC1 are associated to what VLANs. So in our case, all of these ports here for the server VLANs are the trunk ports that connects to the other switches. Another VLAN command that we can use is the same command, but including brief at the end, show VLAN brief. And that will show pretty much the same thing, but it won't include the VLAN type or the mode. It will just basically show the list of VLANs and the ports that it is mapped to. Now we can use any of these commands on the other switches like DCA1, for example. Let's go to that tab. Let's type in show VLAN brief. And there you will see the VLANs that we added on that switch, including ports that are associated to those VLANs. So for example, we know that server 1 is connected to DCA1. Server 1 is connected to port Ethernet 1.1, which we assign to VLAN 10. Another command that we can use for monitoring if an interface is a trunk port, an access port, what VLAN is assigned to, is the command show interface status. And I like this command for a number of reasons. For one, we can get a snapshot of the status of our interfaces, whether they are connected, not connected, or if an SFP optic module isn't present on that switch port, like right here. So for our environment, we know that these ports right here, and this one right here as well, that these ports are used on DCA1 and they reflect a connected state. So these ports right here connect up to the core layer, and this one here connects to our server 1. And we know that we put port Ethernet 1.1 into VLAN 10, our infrastructure network. And we know that the uplink ports that connect to the core layer are enabled as trunk ports. Now you'll also see in our configuration, you'll see the speed and duplex of those ports, that these are 10 gig ports, and you can even see the optic that is used on the particular slots in those switch ports. So we can run the same command, for example, on other switches like DC1. Let's go to our primary core switch here. And let's go ahead and do show interface status. Okay, and there you see several ports that are connected, which is basically reflected right here. You see some connected ports, and here as well, and that they are in a trunking state. So these are trunk ports that connects to the other access switches and to the other data center switch. And of course, you will see the speed, duplex, and the SFP or the optic that is used for those particular ports. Another useful command that we can use is similar to show interface, but it is show interface trunk. And the name for this command speaks for itself. So here we can view all interfaces that are enabled for trunking, which is reflected right here based on our topology. We even see the native VLAN that we set for those interfaces. And we can see what VLAN tags are allowed over these trunk interfaces based on what we configured with the trunk security. So let's go to DCA1 and let's issue the same command of show interface trunk. Go down and do show interface trunk. And here we see pretty much the same thing in terms of which ports are trunking the native VLAN to the VLANs allowed on that trunk interface. Another command that I want to cover is viewing the status of a specific interface on a Nexus switch, similar to what we would do on any Cisco iOS switch. So on DCA1, let's view the interface status of Ethernet 1/1. Okay, so this interface connects directly to server 1 in our environment. If there are any issues where the server is unable to communicate beyond this interface, it's probably best to confirm if this interface is up and not experiencing any errors. So for this switch port, we do see that this interface is up and operational. We see that this port is an access or an edge port, which is reflected right here where it says port mode is access. And this means that this port is intended for edge type devices like endpoints, a server, or a desktop, for example. We also see the speed, the duplex, and the media type for this port. We can also view the traffic rates right here, inbound and outbound in 30-second intervals for this port. I like to look here to confirm the amount of traffic in bits per second that is occurring on a particular interface. We can also view any receive and transmit related errors on this port. The important ones are typically something like the number of collisions that you see here, including the different types of input errors and output errors that could be received. Whenever there is an issue with a server, such as slowness or connection drops, I always check the switch port that the server is connected to and confirm that there are no errors reflected for any of these things here. These could be things like, as I said before, collisions, could be CRC errors or runts, basically any kind of input or output errors. And they're typically caused from a number of things. They're caused from speed and duplex mismatching. That's a big one I've seen too many times. Cabling faults, or if there is high traffic on the port and packets are being dropped because the port buffers are full. Or maybe the server is unable to keep up with the traffic demands. Hence, it may be useful to enable flow control on that port. Now for this port, flow control is disabled, and that is the default for all switch ports. You have to manually configure that. Another thing to look here is the counter value for the interface resets, which is 1, including something that says link flapped, which is reflected right here, last link flapped at a particular time. Now this indicates the number of times this interface has gone down. So this interface was down about 12 minutes ago, and when we issued a no shutdown, it brought this interface up. But looking at the details can be helpful to see if an interface is going up and down and very often. This can help especially if a server is reporting connection drops. In that case, it's best to view the number of interface resets for that port. Now let's view one of the uplink ports that connects up to DC1, the primary core switch in our data center. We'll pick on this one here. Okay, so this is a great command. So there we see a lot of good things. We see the interface is up. We see that this is a trunk port, which is reflected right here. We see the current traffic rate on that port reflected for inbound and outbound traffic, not much, which makes sense in our environment. And of course, we see no errors reported on this interface for receiving or for transmitting. We do see there has been 2 interface resets on this port, which could have been when we were actually enabling or disabling these interfaces. That probably happened during this particular phase. And of course, last link flapped about 12 minutes ago, the same time when we were configuring all the interfaces on this switch. With everything that we have configured in regards to BTP, VLANs, and trunking, we should be able to reach our 2 servers from any of our core switches. So let's go ahead and ping server 1 at the IP of 10.0.0.1. Okay, let's wait a little bit. Okay, ARP has to catch up with us. Let's do it one more time. So we have reachability to server 1. Now let's confirm if we can ping server 2, which is connected off of DCA2. So that'd be 10.0.0.2. Let's let ARP do its thing. Great, so server 2 is also reachable. Fantastic. Now let's confirm if we can ping the Vlan 10 IP address on DC2. So 254. And that is also reachable. Since those IP addresses are reachable, we will be able to view those entries in our ARP table. So here on our core switch, the primary core switch, DC1, let's go ahead and type in show IP ARP. That will show the ARP table. And there we see server 1, we see server 2, and DC2 with its IP address mapped to its MAC address, including the correct Vlan interface. This means when we pinged those IP addresses, our pings were sourced from the Vlan 10 SVI interface. Remember, Vlan 10 is extended throughout our entire data center topology. Now, using the information from the ARP table, we can determine where those IPs exist in terms of which ports they are connected through. This is very similar to how we would do this on a Cisco Catalyst switch. So let's say that we want to view the MAC address table for devices that exist in Vlan 10. So to do that, that particular command will be show MAC address table dynamic Vlan 10. And there we see 3 entries, one for each entry in our ARP table. So for example, server 1's MAC address ends in 203F based on the ARP table, which we see right here. Okay, so in the MAC address table, it's reflected that server 1 is connected off of Ethernet 2/11. This is one of the interfaces that is directly connected down to DCA1, which is where server 1 exists. From there, we will go to DCA1 and let's view the MAC address table for Vlan 10 using the same command. Dynamic and Vlan 10. Okay, so there you see the server 1 MAC address right here, the first entry ending in 203F. And you see that it is connected off of port Ethernet 1/1. That is the actual port that our server is connected to. So this approach is the best way to locate which port a specific device is connected to. So number 1, you want to first check the ARP table, likely on the core, enable for routing, and you want to look for the IP of that device. Then you will get the MAC address details. Then you can use that information to reference the MAC address table on each device to locate where it connects to. Anyhow, that will conclude this video for knowing how to configure and to manage monitor VLANs in 802.1q trunking in our data center environment.